All right, time to get started. Welcome back. I hope you all had a good weekend. We do have our next homework assignment that's due tomorrow night. Somebody just informed me I haven't yet put the thing in Gradescope for you to upload it. Sorry about that if you've already done it. I'll do that sometime this afternoon probably. Please let me know if you're having Gradescope issues. I will try and help out. And let me know if you have questions concerning the homework assignment. Actually, one thing I wanted to say about the homework is I graded last week's homework and quiz. So the next time you log into Gradescope, you should be able to see your grades. Just a note about the grading. So the quizzes, I'm always just going to grade out at 10 points on the quiz. So hopefully you got 10 out of 10. Most people got 10 out of 10. The quiz was pretty routine in my opinion. The homework assignment, the way that I'm going to grade the homeworks is I'm going to choose, people ask me, like, is it based on correctness or completion? And it's a little bit of both. So the way it works is I'm going to choose 4 questions in detail, grade those 4 questions, in detail. I said that already. And then you also get some points for did you do the whole assignment. So the way it works out, you can check your graded assignment in Gradescope. I picked 4 questions. You got 3 points for each of those 4 questions, plus an additional 3 points for did you do the whole assignment. So it's out of 15 total for the homeworks. I don't know if you remember what I just said, but I would be happy to tell you again if you forget. The quizzes are always out of 10. The homeworks are always out of 15. That's the short version. All right. Any questions about that? Great. Check them out. So when you see your old assignments in Gradescope, you can see your grade, of course, but you can also see like my detailed comments about your answer. So if you got something wrong, I probably wrote something about why it's wrong. Hopefully that will be good enough for you to understand like what you should have done instead. In case that is not clear enough, I have also written out my own answers to the questions that I graded, and I posted them on the website right next to the assignment. So if you're ever unsure about, like you got something wrong and you're not sure why, hopefully my comments are helpful, but if that's still not convincing you, then check out my answer and see how I did it. And of course, if that still doesn't make sense, then I'm happy to explain by email or in person. All right? Great. Okay, next homework is tomorrow night, due tomorrow. One last thing about the homework. I would appreciate it, and I think you will appreciate it too, if you don't try to print out the assignment and then write your answers like in between the questions. This is not meant to be a worksheet, and I did not leave enough space in between these questions for you to do that. A few people printed it out and then just like a whole bunch of scribbling in the margins, which looked like a crazy person. You did it right, but you look like a crazy person. So I intend for you to use your own paper. I suppose if you don't print it out. All right. Any thoughts about that? No. Just look at it on your screen or print it out. Put it next to your other paper and write your answers on your other paper. All right. Great. Some people wrote the whole thing like on an iPad or something. That's totally fine. Do whatever you like. Okay. At the very end last time, I think we left it we were talking about the Borda count, the Borda method, which is the one where you add up the points. And I said, let's do the Borda on this thing. This was the election about the best movies ever. And I got kind of fed up with that at the very end last time. Let's actually do the Borda here. I'm just going to do one of them, and I did the rest ahead of time. This took me about 10 minutes to work through all the numbers, which is why I don't want to get too bogged down with it here. But I hope we all remember how to do the Borda. That's the one where you add up the points according to what position the rankings are in. And the points always go 0 for last place. So in this example, it's 0 for last place, and then 1, 2, 3 up. So the top position gets you 3 points. I'll put them over here too. All right, those are the points. And the way you do the Borda is you multiply the point value times the number of voters who put it in that position. So this H right here is earning 3 points from 1 voter. And so that is a 1 times 3. And then I add on this position is earning 3 points from 4 voters, which is actually 4 times 3, which is 12. So I'll write this as 1 times 3 plus 4 times 3 plus. And then I'm just going to go down the whole list here, each time finding the H and then multiplying the appropriate numbers. So the next one, the column with the 2 on top, has a H in the 3-point position. So this is 2 times 3 plus a 1 times 0. That's the first one column there has H on the bottom. And then plus another 1 times 0. And then the 5 column has 2 points for H. So that's plus 5 times 2 plus 1 times 2 plus 6 times 1 plus 1 times 1. I hope everybody's following this. The 6 times 1 comes from this column. I'm doing this kind of fast, but it makes me feel insane when I do this kind of thing, just because it's a whole bunch of adding and multiplying, which is not my jam, really. I'm on this column now. H in the 2-point position, so that's going to be 1 times 2 plus another 1 times 2 plus the third to last column has H getting 1 point, so that's a 1 times 1 plus second to last column 2 times 1 plus the very last column 2 times 0. All right. This is the kind of thing that people think mathematicians do this all day long. They don't. At least I don't. I don't want that. All right. Any questions about how we got all that? It's a whole bunch of nonsense, really. But now let's add it all together. Like I said last time, make sure you multiply first and then add everything. So I'm going to multiply these on paper. It's 3 and then plus a 12 here, and then a 6 and then a 0. 5 times 2 is 10. 1 times 2 is 2, and then a 6, a 1, a 2, a 2, a 1, a 2, and a 0. Right? And then you add all of that together. You can use a calculator, of course, if you want to. I did this and I got 47. I hope that I didn't mess it up, although it's, it's certainly possible. It's easy to mess these up, especially when it's this big. A typical problem like this that I would expect you to do on a quiz or something would be much, much smaller than that, although I think everybody could do this if you had to. Okay, that's the number for the H. You do the same thing for the L and the S and the T. I don't think we need to go through the details of all that, but I'll tell you the answers just in case you're curious. I did this for the L, I got 30. For the S, I got 62. Each of these you would have to compute in the same way. For the T, I got 35. Just for the sake of telling everybody the results. All right? And so the winner using the Borda is S, Star Wars. And we've done this example now 4 times with 4 different methods, and we got Star Wars every time. That suggests to me that the people are really into the Star Wars, at least as far as these 4 options go. There does seem to be pretty decent consensus among this class that the Star Wars wins with Borda. All right. Any thoughts about that? This is like the biggest and nastiest example you would ever do. All right. Of course, like I always say, in the real world, when you do elections like this, you do everything with computers, and the computer can do this very easily. So it's a pain to do by hand. It's not a pain to do in the real world. All right. Excellent. Thank you for your attention with the Borda. What I want to talk about today, that was just sort of a leftover from last time. What we're going to talk about today is actually something completely different. As I've said a couple times about just like our basic, the basic structure of what we're talking about with this voting thing is, first of all, can we talk about different ways of doing voting, different systems? And we've talked about 4 different systems now: the plurality, the ranked choice, the Condorcet, and the Borda, right? And then the second thing that I want to discuss is how can we judge which of these systems is better and which is worse? Now, I've told you some kind of informal thoughts about plurality versus ranked choice. I kind of like the ranked choice. I think it is a nice thing to use in the real world. But certainly, if plurality is the only other option, I personally kind of like ranked choice better than plurality. But this is just sort of my own informal thoughts. What I would like to discuss is specific, like mathematical criteria for judging these systems. All right? Some specific measures that we can use to judge if these are good systems or not. If somebody tells you, yeah, I like the ranked choice better than the plurality, you should be able to explain why. Like specifically, what is better about this or that? We've talked along these lines mostly about ranked choice versus plurality. But what about the Borda? Is that better, even so, than the ranked choice? How come nobody in the U.S. If you know something about elections, you know a lot of people are suggesting that we switch to ranked choice. Basically, no one is suggesting that we switch to Borda. Why is that? Because nobody's ever heard of Borda, or for other reasons. Actually, there are some other reasons that we're going to talk about. Generally speaking, people do not believe that Borda is suited for use in the real world, and it's for some reasons that we're going to talk about. Anyway, criteria. That's the plural of criterion. So today we're going to talk about a few specific measures, ways that you can, specific things that you can ask about these various voting systems. All right. Today we're going to talk about probably 2 or 3 or maybe 4 different criteria, depending on how far we get. I'm going to start with some simple criteria based on people's, well, let me say some simple criteria based on choosing the winner if there is a clear favorite. All right. The difference between these systems usually only matters when it's kind of a close race. If the people's opinions are somewhat divided, then it may be that if you change the voting system, you'll get a different result. But in the cases where pretty much everybody agrees from the outset, then the system, if it's behaving correctly, should more or less choose the candidate that everybody is agreeing on. So I actually have 2 different criteria towards this end. Actually 3. Sorry, something's a little weird on my paper, so that's fine. Choosing the winner if there is a clear favorite. So the basic principle behind this is if there really is a clear favorite, then if your system is good, then it will choose the one who everybody likes, right? There's actually 3 different ways of saying that, 3 different very specific, like mathematically measurable ways of saying that. The first one is called the majority criterion. The majority criterion. So this is a specific way that you can measure if your voting system respects the will of the majority. So this is what it says. It says if there is a candidate ranked first place by a majority of the voters. Remember, majority means more than 50%. This is why it's called the majority criterion. More than 50%. Majority does not mean they got the most votes. It means they got more than 50% of the votes, which is a little stronger. Yeah.
Is the majority only more than 50% when there's 2 candidates? As the percentage changed?
No, always more than 50%. So the word majority always means more than 50%, even if there's 10 people in the election. So if there is 10 people in the election, you would probably expect that this doesn't happen. Probably nobody's going to make it to 50%. But I'm saying, if there is a situation in which a candidate is ranked first place by a majority, this of course means the people really like that one. Then this candidate should win the election? All right. This is a pretty, I would say, a pretty ordinary sounding basic fact that you feel like this ought to be true in any democratic system. It should behave in this way. That if there is somebody who is ranked in first place by a majority of the voters, that person, that somebody should win the election. And we can ask, do our 4 different systems actually satisfy this property? Like, I'm not saying every possible way you could vote automatically satisfies this. I'm saying this is one way that you can tell if a system is good or not. Does it obey this property here? So we can ask, do our 4 systems obey this property, right? I will say parenthetically, hopefully. I feel like in some kind of informal level, a good voting system should probably obey this basic principle. If a majority of the people put somebody in the first place, that person should win the election. That's not guaranteed, though. I mean, we need to actually think it through. And let's think about our 4 different voting systems. You know, the plurality, the Condorcet, the Borda, and the ranked choice, right? Do they actually behave in this way? Let's think about plurality. Is it really true? If you have a candidate who is ranked in the first place by a majority of the voters, do they automatically win the election if you're using the plurality system? That's what I want to know. The answer to that question that I just asked is yes. If you have someone in the plurality system voted in the first position by a majority of the voters, they will automatically win the election. So the way to say that is, I'm going to say plurality does satisfy the majority criterion. All right? And that's because, well, actually, let's just try to, let's explain why. This would be like a typical homework question about this. Involves no numbers or anything. It's just explain to me why the plurality system satisfies the majority criterion. What you have to do in your explanation, remember what I'm trying to explain is this stuff here. If there is a candidate ranked first place by a majority, then this candidate should win the election. You have to explain why that actually happens when you're using the plurality system. So I'm going to say something like, you have to write a few sentences here. I would say 3 sentences probably will do it. Imagine, let's say X is ranked first place by a majority. I'm going to give you like a little template here. Then blah, 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 blah. This you got to fill in. And then your last sentence. So X wins the election. All right? If you're trying to explain why something or other satisfies the majority, this is what your explanation must consist of. You begin by imagining someone is ranked in the first place by a majority. You make some kind of explanation of something describing, explaining why that candidate X wins the election. Yes?
For like the 37 voter election,
Yeah.
how like A won the plurality.
Yep.
A didn't have 50% or more of the votes. They just had more than the other ones.
Yeah, that's right.
So then how is that
So
plurality system like actually?
yeah. The majority criterion says if somebody has a majority, then they win.
It doesn't have to be.
Yeah, right. You
50%.
can win in the plurality system even without 50%, but that's not what the criterion is saying. So it says if somebody actually gets a majority in the first position, then they should win, right? Yeah. Yeah, this doesn't always happen in the plurality system, certainly, or in any of the systems. All right. Anybody feel like you can fill in the blanks here? Can anyone explain to me why is it exactly that somebody ranked in the first place by a majority will win if you're using the plurality system? What you fill into the blank here needs to be specific to the plurality, right? Because I'm trying to explain specifically why the plurality system obeys this majority criterion. Can anybody say? Yeah.
Because plurality is when you choose the candidate with the most votes.
Yes, plurality means you choose the candidate with the most first place rankings. So if someone is in the if someone has a majority, does that automatically mean they got the most? The answer is yes, it does. If you got more than 50% of the votes putting you in first place, then you have to get more than anybody else did, because you can't have two people getting more than 50%. So you got to say something like that, and it doesn't have to be very complicated. I'll say something like, then X got more first place rankings than anybody else. That's the point of the plurality system, right? The plurality system is decided by who got more than anybody else. And if somebody got a majority, more than 50%, automatically that means they got more than anybody else. So then X got more first place rankings than anybody else. So they have a plurality, right? Plurality means more than anybody else. And so they win the election if you're using the plurality system. All right? This is the kind of thing that you want to say in a problem like this. Any thoughts about that? So the plurality system does satisfy the majority criterion. What I want to do, and we're going to come back to this very often over the next couple week or so, I don't know. I'm going to make a big chart here with our voting systems. Put this like on its own page or something, because we're going to come back and add onto this chart several times, because we're going to have several different criteria going across the columns, and we're going to say for each of our different systems, we have the plurality, the ranked choice, the Condorcet, and the Borda. Actually, I have one more system that we're going to add in, not today, but anyway, so far we have demonstrated that the plurality does satisfy the majority. I'm going to put a little check right there. All right? And as we go, we're going to add in more and more stuff to this chart. Generally, like a check is good, and I'm going to put a big X when it does not satisfy. All right? So what we're looking for in terms of real world, like systems which are good to use in the real world, I want to pick something with a lot of checks, right? So far, plurality looking pretty good, although this is the majority criterion is a bit of a low bar. It's not necessarily all that meaningful, but plurality does satisfy the majority criterion. All right. I'm going to say the ranked choice. I'm going to put a check there also, although this I don't want to talk about right now. So this is going to be, can I say, on the homework for next week, actually, not the homework for tomorrow, because the homework for tomorrow only covers what we did last week. But one of the questions on the homework for next week will be, explain to me why the ranked choice does satisfy the majority criterion. You would do it just like we did right here, basically fill in the blanks. The beginning and the end will be the same. It's just the bit in the middle that you'll need to change to specifically be about the ranked choice, which is about the rounds, and eliminations. All right. I want you to try the Condorcet right now. So I would like you all to see if you can. It turns out there is a check. All right. I'll tell you that. Your job, and I'm going to walk around and see what you feel about this. Explain why the Condorcet does satisfy. Why the Condorcet satisfies the majority. All right? Your answer should look like this. You should basically have, you don't have to write exactly the same words as I did, but it won't be wrong if you write exactly these words at the beginning and exactly these words at the end. It's just what you explain has to be not about the plurality system, which is about getting more votes in the top than anybody else, but you have to explain something about the Condorcet method, which I hope you remember. The Condorcet is the one where you compare all of the candidates in pairs and you choose the one who wins every possible pairing that they participated in. So see if you can replace the middle bit here with an explanation as to why. You have to explain why if someone is ranked in the top position by a majority, then they're going to win if you use the Condorcet method. I'll give you a few moments to think about it. You can chat with your friends about it if you like, if you got any. It's okay if you don't got any. What you write in the middle, I said, has to be something about pairs. That's because that's the Condorcet method is based on pairing up the candidates. I gave you until the clock says 11:30, and then we'll talk about it. All right, it says 11:30. Anybody want to tell me what they wrote for their sentence in the middle? Probably one sentence would do it. could write more if you like, but I saw some good ones as I was very briefly walking around. How about I will try to write down one that I saw from memory. They said what you got to do is explain why such a person who's ranked first place by a majority is going to win with the Condorcet. It's because, you know, the Condorcet, remember, is the one where you go like, you do like the A versus B, and then you do the, you know, A versus C, etc. If for instance, A was actually in the first place by a majority, it means automatically A is going to win all of these comparisons because A is going to be on top more often than they are on the bottom. That's the kind of thing that you got to say here. I would say, imagine X is ranked first place by a majority. How about this? Then X wins in any pairwise comparison, you know, X versus Y, right? Because if they're in the first place most of the time, then they have to win against anybody else. If they're in the first place more than 50% of the time. Actually, that's my whole sentence, right? Then X wins the election using the Condorcet method, okay? This is a very brief way of saying it. I saw some people said, you know, wrote more words than that, which is probably fine. Some people, I saw more than once, people who kind of wrote this, I think meant the same thing that I meant, but wrote it backwards. Said something like, X wins in any pairwise comparison, and therefore X is the one who's ranked first a majority of the time. You have to write it the other way around, though. It's because we are imagining that X is ranked first a majority of the time. This means, therefore, that they're going to win all their pairwise comparisons. And that means that they win the election when we use the Condorcet method. All right? This is the kind of thing that you got to write in your answers here. All right? This is like a typical, I would ask, you know, a homework question or a quiz question or something. Any thoughts about that?
Any other choice has not beat X.
Yeah, there's no way for anyone to beat X in a pairwise comparison. Right. Yep. All right. Maybe the majority criterion just seems like an obvious thing. Obviously, it's true no matter how you do voting. It's true that if somebody's ranked in the first place the majority of the time, then they're going to win the election. Actually, that is not the case, though. I said no matter how you do voting. There are some voting systems in which the majority criterion is not satisfied. And in particular, actually, BORDA does not satisfy. Can you believe it? I will prove it to you. Let's talk about how do you explain why something does not satisfy one of these criteria. So to explain why some system does not satisfy majority or whatever else, let's talk about majority for now. Satisfying majority means no matter what, if somebody is ranked first place in the majority of the time, then they'll win the election. If you want to show that that's not true, all you have to do is show one particular example where somebody was ranked first place by a majority, but they end up losing. All right, so to explain why, that's supposed to say why there. To explain why some system does not satisfy majority, we need to invent or find in your notes somewhere a particular example in which some candidate X is majority first place, but X loses the election. All right? This actually can happen when you use the BORDA, and this is a major deficiency of the BORDA. This specifically is not the main reason why people don't use BORDA in the real world, but this is one reason why you might not want to use BORDA in the real world. Here is an example using BORDA. So BORDA does not satisfy majority criterion. Here's an example. This is not all that complicated. Let's say 3 people say ABC, 2 people said BCA. All right? And I'm going to use the BORDA, okay? First of all, Who is ranked first place a majority of the time? Anybody? A is ranked first place by a majority of the voters. There are a total of 5 voters here, right? 3 plus 2. And 3 out of 5 of them are putting A in the top position. So that is a majority of the voters. A is ranked first by a majority of the voters. In this particular example, it would be 3 out of 5, right? There are 5 total voters, and 3 of them are putting A in the top position. But let's see who wins the election. If I add up the points, doing the border here, the points go 0, 1, 2. 0, it always 0 points on the bottom. When I add up the points, A gets, all right, 3 times 2 from the first column, and from the second column they get 2 times 0. That adds up to 6, right? 6 plus 0 is 6 points for A. B gets 3 times 1 in the first column and 2 times 2 in the second column. That is 7. B actually wins when you use the border here. And C, just for the sake of, C's not going to win, but C gets 3 times 0 plus 2 times 1, which is 2 points. B wins. All right? And so, in the border, it is possible to have one candidate ranked in the first place by a majority of voters, but somebody else wins. All right? It's because, just because of the way the points works, it's sort of possible to like get a bunch of points from being in second place and make you win the election, even if somebody else was in first place a majority of the time. All right? This is generally viewed as a bad thing about Borda, just because it seems kind of wrong that this could happen. But, you know, by the numbers, it can happen. All right?
How did you get 6 on A? It's 3 times 2.
Yeah, 3 times 2
6.
plus 2 times 0. This is 0, because anything times 0 is 0.
Wouldn't that be 8?
No, you got to do the multiplications first when I write in this order. So you should do 3 times 2, which is 6, plus 2 times 0, which is 0.
Oh, it's 2 times 0. Ah, I'm sorry.
Yeah, 2
Okay.
times 0.
Got it. Okay.
Yep.
Thank you.
All right, so this is something that's kind of bad about Borda. It does not satisfy the majority criterion. All right, so put this chart in your notes somewhere. We're going to come back to it often. I mean, including like in a few minutes, we're going to come back to it with another, more and more, we're going to have several different criteria. And so when you're like arguing with your friends at lunch about what's the best voting system, this is one way you can try to discuss it. You can say, oh, Borda is terrible because it doesn't satisfy the majority criterion. It's true, Borda doesn't satisfy the majority criterion. You can debate amongst your friends, like how important exactly is this in the real world? My answer to that question is kinda. I mean, people will disagree about exactly how important this is. Is this a real deal breaker? If you see an X in this column, does that mean you absolutely should never use that system in the real world? I wouldn't go that far. These are just, we're going to talk about many different ways that you can try to judge these systems one against another. And in terms of the majority criterion, the Borda comes up a little short compared to the other ones.
But
Yeah.
in our system here, in this country, we have an electoral college, right? So you can win the majority and still lose the election.
Yes.
The majority of
According to
popular
the,
votes,
yeah, right. Yeah, the electoral college is something kind of outside the scope of these methods. In the United States, we do something more like 50 separate plurality elections, and then you add the points together after that, which is, I mean, it's more complicated than any of these individual systems. We actually are going to talk more about the electoral college in a couple of weeks. So if you've been itching for the electoral college system, we are going to talk quite a bit about that. But it doesn't exactly fit into this method. This in the context of American politics, we would more likely be discussing using these systems individually within the states, and then you do the electoral college. It's hard to change. You can't really change the electoral college without changing the Constitution, which these days the Republicans would never go for that, because right now, in the current landscape, the electoral college is benefiting the Republicans to a large extent. Yes.
For their ranked choice voting, doesn't it not always satisfy the majority? Like a motto or whatever won the plurality, but then the other guy won the ranked choice.
Yes. Remember, to satisfy the majority means if somebody has a majority in the first place, then they're going to win. But in that example, nobody had a majority. This is similar to the question you asked before. Nobody actually has 50% in the first place in that example.
So then doesn't the plurality not always satisfy the majority?
It does always, because
You can win the plurality without having 50%.
that's right. This is not what the majority criterion is about. The majority criterion says if you have 50%, you're going to win. What you're asking about is if I won, does that mean that I had to have 50%? The answer is no. That's something else, though. It's like these two things. When you change it the other way around, it really means something very different. Like if I live in Fairfield, does that mean I live in Connecticut? Yes. If you say it the other way around, that's not true, though. If I live in Connecticut, that doesn't mean I live in Fairfield. So majority says if you get more than 50%, you're going to win. The other way around, if I win, that does not necessarily mean that I'm going to get 50%.
Okay.
Yeah, this is an important, subtle distinction. Thank you for raising that. All right, that's all we're going to say for now about the majority criterion. It's a fairly easy criterion. We're going to talk about more and more complicated criteria for deciding voting systems, if they are good or not. Here's a very easy one, maybe even simpler than the majority. I don't know. How about this one? This is called, I'll just say this is an even simpler one. And maybe this also kind of gets to her question. This is called the unanimity criterion. This one is not just about if more than 50% of the people happen to agree about somebody. This is about unanimity. If it is actually unanimous that everybody likes somebody better than another. This one, the way that the unanimity criterion is written, it's not about first place rankings, but here, I'll tell you what it is about. It says if X is ranked above Y by all voters, then, anybody say what should happen in that case? This is not a hard question. X should be the winner. Actually, this was somewhat of a trick question. That's actually not what I'm about to write here. It's not quite that, because actually if you say X, everybody prefers X above Y, that doesn't necessarily mean that X should win, because maybe there is somebody else who everybody likes even better than X, right? If there are many different options, it's like, just because X is better than Y in everybody's opinion doesn't necessarily mean X should be the winner, but it does mean that Y should not be the winner. That's what I'm going to say here. So if X is ranked above Y, I kind of set you all up for that, I know. If X is ranked above Y by all voters, then Y should not win. That's what the unanimity criterion says. All right? It is a common misconception to conclude that X should be the winner. So let me just say parenthetically, X might not win if there is some other more popular option. So we are not going to conclude that X should be the winner, but definitely Y should not be the winner if there's somebody else who everybody thinks is better. All right? The unanimity criterion. I want to talk again about which of our systems satisfy the unanimity criterion. I'm going to go up to my chart here, my next column here, unanimity. Turn your pages back. You could put this one on your refrigerator or something. If X is ranked above Y by all the voters, then Y should not win. Can we just think about, let's just think about plurality. Maybe I'll say it out loud and then we'll write it down. Does the plurality satisfy the unanimity? So if you're using plurality and everybody likes X better than Y, Is it possible for Y to win the election? I don't think so. Like I said, it doesn't mean that X is going to win, but definitely Y is not going to win if you're using the plurality, right? So I'm going to try to explain that. Let's say plurality does satisfy. It really does satisfy unanimity. And here's my explanation why. I'm going to format it in the same way. Remember, when you're doing majority, you have to imagine that somebody is ranked first place all the time, or a majority of the time. When it's unanimity, you have to imagine, like it says in the unanimity criterion, if X is ranked above Y by all voters. So I'm going to say, imagine X is ranked above Y by all voters. All right, and then something, 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 and then so X, not X wins. Sorry, that's the classic blunder. So Y does not win. That's what you have to conclude using plurality. All right. We need to explain, fill in the blank in the middle there with probably just one sentence would do it. Explain, can anybody explain specifically? In a plurality, if X is above Y, can you explain why Y does not win the election? X is always above Y, yeah.
Y will never be in first place.
Yeah, Y is never in first place, so when you do the plurality, their total is 0, right? And so they're not going to win. That's what you got to say. Excellent answer. So I'm going to say, I'm just going to like underline these parts, because when you do another example, you should leave those parts exactly the same. The only part that matters in terms of plurality is what I'm about to write in the middle here. And you better say something about how many rankings you get in the first place, because that's what the plurality system is all about. So I'm going to say what she said. Then Y gets 0 first place rankings. And I think that's all you need to say, right? Y gets 0 first place rankings, so Y does not win using plurality. All right? You better say something about first place rankings, because that's what the plurality system is all about. If you give me some kind of, sometimes I see some people just give me some kind of wishy-washy nonsense about, if X is ranked above Y, then truly nobody thinks that Y should be the true winner of this election, and so therefore Y does not win. You got to say something about the plurality system in particular. Now, I didn't use the word plurality in here, but I'm talking specifically about how many times they are ranked in the first place. That's what the plurality is about. All right? This is how you show the plurality does satisfy the unanimity. I would like you guys to try one like this. So try this, but think about ranked choice. I'll tell you ahead of time, ranked choice also does satisfy the unanimity. So all you need to do is write these same 2 sentences at the beginning and the end. Change the word plurality to ranked choice. But in the middle, you're going to have to say something a little bit different. You have to say something about ranked choice, which is about the rounds and eliminating people, all right? Explain why is not going to win the election. Somehow mentioning rounds or elimination or something like that, because that's what the ranked choice is about. I'll give you until 11:51 on the clock. It won't take long once you know what to write. It's only a sentence or so. All right, it says 11:51. Anybody want to tell me your sentence? Yeah, thank you.
I said then y gets eliminated because it has less votes than x.
Yes. Then, in fact, she said y will be eliminated because, in particular, they have less votes than x. I think actually you can be a little more specific. Can you say, like, when will y be eliminated?
I said
Y
y always loses in pairwise comparisons.
always loses in pairwise comparisons with x. That's true. Although, yeah, your answer, that would be more appropriate if you're talking about the Condorcet method, which is about pairwise comparisons. Here you need to say something about eliminations and the rounds with the rank choice. Yeah.
I said y will be eliminated before x.
Y will be eliminated before x. Yeah, that's true. I was going to say all of these are good answers, but I was going to say something even more specific than that. Maybe.
If it's just those two, the first round.
Yeah, and actually, even if there are others, Y never ranks in the first place, so they're automatically eliminated in the first round, right? Because when you count up the ranks for like round one in the rank choice, Y is going to have 0, and so they're definitely not going to win though. So any of those answers.
Above like other candidates.
What's that?
Can't y be like hypothetically ranked above other candidates though, just below x?
Yeah, but Y can never be on top. Like, when it goes, your rankings could look like, say, X, Y, Z, in which case Y is above Z. But you could never have Y, Z, X. Like, the Y cannot be on the top because the X is always above. And so that means Y gets 0 votes in the first position, and so in round one they will be eliminated. But anyway, let's say.
But it is a possibility that y doesn't get eliminated in the first round because there are different possibilities during rank choice voting. So that's the same that we might have a candidate above x. It doesn't get stated that there's a candidate below y.
Y must be eliminated in the first round. I'm sticking to it. Because the only way that Y can survive the first round, in the first round you first decide what are the totals for everybody, like in round one, right? Y's total is automatically 0 because X is always above Y in everybody's ballot.
Oh, and for ranked choice they have to be in first place.
Yeah, in ranked choice you count up how many times these people are in first place, and Y can never be in first place because X is always above Y. Right? Yeah?
Yeah, I mean, I'm thinking about the Alaska
Yeah, right.
example
Mm-hmm.
where y might be Sarah Collin, and then
Right.
you have x being Bertola and c being the other candidate.
Yeah.
So even though y didn't win the election, it was eliminated in the further process.
Yeah, right. But in that case, you didn't have this unanimity thing. The unanimity, we are imagining a scenario where all voters put X above Y, which did not happen. This basically never happens in the real world, where all of the voters are in agreement about two of the candidates. Yeah. Okay. What am I going to write here? I'm going to write. Imagine all voters rank. There are many ways that you could fill in the blank here. I will say something like, then Y gets no rankings in the first place. That's because X is always above Y, so Y can never be ranked in first place on anybody's ballot. So Y is eliminated in the first round. And therefore Y does not win the election. Right. I'm writing right across the page break. Those of you who like to print everything out, it just helped you out a little. All right. As he said, this is a fairly unrealistic scenario to imagine in the real world when you do a real election. It's never the case that every voter agrees about this person is better than this other person, because there's always some wacko out there who would put them the other way around. All right, but this is more of a mathematically interesting criterion. So I'm going to put a check here. Oops. Plurality, that's the one I did, and then this rank choice is what we just discussed. All right. The unanimity, I would say, is not something that comes up in the real world, but it's still a useful mathematical thing to consider, because if your system did not even respect the choices of the voters when they were unanimous, then certainly your system is not going to work appropriately in the real world. That's the idea behind this.
Will these like be on the quiz?
Eventually, not this week. The quiz on Friday is always about the homework, which was due on Wednesday, and this stuff will not be on the homework for tomorrow. Yeah, everything has like a week delay. All right. That's the unanimity criterion. It is satisfied by both of those things. And I'm just going to tell you, because these I'm going to put on the homework also. The Condorcet and the Borda also satisfy the unanimity. So don't just believe me for now, but these are also going to appear on the homework. They will be checks. Basically, any reasonable system that you can think of will satisfy the unanimity. If your system does not satisfy the unanimity property, that means that it somehow ignores people's opinions even when they are unanimous, which is not a good idea. Like that sounds very undemocratic to me. And so ordinary voting systems that you are likely to come up with are going to satisfy the unanimity property. And if somebody suggested to me, hey, why don't we change to this other system? And if someone suggested to me changing to a system which does not satisfy unanimity, that's like a major red flag to me. I would say, I don't like that because it does not satisfy the unanimity property.
Literally a red flag.
A red flag.
Literally.
All right, that's the unanimity property. You ready for another one of these? I got one more for today. It is more sophisticated than these other ones. It has to do with comparing the candidates in pairs. So that's the basis of the Condorcet voting method. But even if they're not using the Condorcet method, you can still ask how these systems respect pairwise comparisons. And that's what this next and for today last one is about, although it's not the last one forever. This is called the Condorcet Winner criterion, which I'm going to write CWC. The Condorcet Winner criterion. This is about pairwise comparisons. I'll just write it down what it says. It says if all of these criteria are of this format, if something or other happens, then this or that should happen for the winner. All right, and this one is going to say if I'll just say this way, if there is a Condorcet winner, remember what that means is that this means somebody wins all their pairwise comparisons. Then that candidate should win the election. All right. This was Condorcet, the man, Condorcet, his idea about telling whether a system is fair or not is if there is someone who actually would have beaten anybody else in a pairwise comparison, then they should probably be the winner of the election overall. All right. This is called the Condorcet Winner criterion. And for this one, we get kind of a freebie on the chart. There is a check here. The Condorcet method does satisfy the Condorcet Winner criterion. That's because the whole point of the Condorcet method is that the definition of the Condorcet method is that it chooses the Condorcet winner to become the winner of the election. That's how the Condorcet method works. You find the Condorcet winner and you make them the winner of the election. But these other ones, we can still ask about these other ones. For example, plurality. Is it true that When there is a Condorcet winner, that is somebody who wins all their pairs, do they automatically also become the winner if you're using the plurality system? Or if you're using the ranked choice, or if you're using the Borda? This is what I want to talk about for our remaining 14 minutes. If somebody is the Condorcet winner, are they necessarily going to be the winner of the election overall using those other systems? All right. This is what I want to talk about. Let's talk about plurality. So plurality and the Condorcet winner criterion. So the question is, if let's say someone wins all their pairwise comparisons, will they win the election if you're using plurality, right? Like, is that winning all those pairs, is that good enough to make sure that you automatically get more votes than anybody else in the first place? Because that's what plurality is about. Any thoughts about that? Maybe it is true, or maybe it's not true. I mean, maybe you could think, have we had any examples in the past where somebody would have won all their pairs, but they ended up losing the plurality? Is that even possible? That's the kind of thing that we're trying to think about here. Actually, I don't know if you can just immediately remember every example we've ever done. I kind of can't because I made them up, or I've been doing them. But we have talked about an example like this where there was somebody who would win all their pairs, but they end up losing the election with the plurality. Anybody remember?
Was it the Bush v. Gore?
Yeah, the Bush-Gore-Nader thing. In that election, it is true that Gore would have won if it was just Gore versus Bush. And also if it was just Gore versus Nader, then Gore would have won. That means that Gore was the Condorcet winner. But, of course, using the plurality, Gore did not win the election. So the answer right here to this specific question that I wrote is no. And the reason is, it is possible to win all of your pairs but still end up losing the election if you're using the plurality system. So I will just remind us, in the Bush-Gore-Nader thing, Gore was the Condorcet winner. That means, remember, that he won in any possible pairwise matchup. Bush versus Gore alone, Gore would have won. And also Gore versus Nader, Gore would have won. But in the plurality, Gore lost. All right. Therefore, on that chart there, you put an X with plurality and Condorcet. Plurality does not satisfy the Condorcet winner criterion. And this is a bad thing about plurality, all right? I get an X right there. Plurality does not satisfy the Condorcet winner criterion. And if you talk to, typical person on the street who knows something about this, which is almost nobody, this is one thing that people will say, what's so bad about the plurality system? This is one thing that's bad about the plurality system. It does not respect the Condorcet winner. Even if somebody would have won the election in every one-on-one competition, they still might lose in a plurality election, which seems somehow kind of wrong, at least to some people. All right. Certainly, Sir Condorcet himself would not like the plurality system for this reason. All right. What about the ranked choice and the Borda? Does anybody remember examples like this, perhaps, where there was a Condorcet winner, but somebody else was the ranked choice winner? Is that possible? Or the Borda? Actually, we did have an example that I know at least one of you remembers. Somebody mentioned it already today. We had an example in which the Condorcet winner was a different person than the ranked choice winner. You remember that? This actually was the big, the example on the handout. I was referring to her because she mentioned it already earlier today. In that example, remember the handout example. If I did plurality, I don't know if you remember this, I looked this up myself. When I did plurality, the winner was A. When we did, I just want to get this right. When we did the Borda, the answer was B. When we did the Condorcet, the answer was C. And we did the ranked choice, the answer was D. All right? So in this example, you can see that C was the Condorcet winner. But C did not win using the plurality or the ranked choice or the Borda. That means actually that like this problem with plurality, it is a problem with plurality that the Condorcet winner doesn't always win with the plurality. But actually the same problem exists with ranked choice and also Borda. So this X in the chart there is not, I mean, it's bad for plurality, but there's also an X here and here, all right? The ranked choice and the Borda also do not always choose the right winner with respect to the pairwise comparisons, all right? And so if you were talking to the guy on the street who said, oh yeah, plurality is terrible because it doesn't satisfy the Condorcet winner criterion, you could say, yes, you're right, but you know, neither does the ranked choice or the Borda. So they are, as far as this goes, these other methods are no better than the plurality. The Condorcet is better, of course. But remember, the 3 checks here is a little misleading about Condorcet. This would suggest Condorcet is like the awesomest system ever. Anyone remember the big problem with the Condorcet system? Yeah. Yeah, sometimes you don't get a winner, and then you're just screwed. So this system is not really is not appropriate for use in the real world, although we can still discuss its mathematical properties. It is, in many ways, mathematically really awesome, but not practically useful because it doesn't always choose the winner. All right. I think maybe we'll leave it at that, if that's all right. We're gonna, I've got 2 more criteria to discuss next time. See you all then. Let me know if you have homework questions. I'll hang around for a few minutes. I'm happy to talk about the homework.